بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين سيدنا محمد وعلى آله وصحبه أجمعين. This is Dr. Tariq Halqam. Today we will start talking about the third topic in this syllabus, which is about the waves. In our syllabus for this topic, first of all, we'll talk about the basic variables of the waves, like certain definitions that are related to the waves, like progressive waves. Describe what is meant by the wave, vibration drops, spring, ripple tanks. Understand these concepts, displacement, amplitude, phase. Deduce from the definition speed, frequency, this wave equation. Recall and use this wave equation. Understand the energies transferred by progressive waves. Also recall and use the relation between intensity and amplitude. The second part about transverse and longitudinal, the difference between them graphically and by definition. Determination of frequency wavelength using cathode oscilloscope, Doppler effect, and electromagnetic spectrum. This is the first part, which is the basic variables of the waves. The second part, which is about the behavior of the waves, we will consider the diffraction, interference, and the diffraction grating. The last part talks about what stationary waves, right? Stationary waves. Here there's a certain, or let's define the progressive waves. It's a disturbance or oscillation that travels through the space and matter combined by transfer of energy. Wave motion transfers energy from one point to another. These are the basic or the properties of the waves in general. All the waves have repeating pattern. They carry energy without moving material. All waves have wavelength, frequency, amplitude, and time period in order to describe this wave. And finally, the speed of the wave, right, depends on the medium that is traveling in it. Propagation of waves means the direction in which wave travel. You propagate right or left, no matter. Transverse wave, which you are familiar with this concept. The transverse wave are waves that where the displacement or the oscillation is perpendicular to the direction of travel. Yani this is the oscillation, up and down. This is the direction of travel. If the oscillation is perpendicular to the direction of travel, perpendicular to the direction of travel, this wave is called what? Transverse. Transverse wave it's a series of what? Crest and trough, like this. This is a crest, right? This is what? A trough. Okay. A single wave here consists crest and trough. This is single wave. Longitudinal, guys, and displacement or oscillation of particles is parallel to the direction of travel. And if I can represent this like this, we have oscillation. We have direction of travel. الcompression طبعا regularly longitudinal waves or sound waves consist of mainly two regions, compression and what? Rarefaction. Compression, the region where molecules are closer to each other and have high pressure. Rarefaction, the region where the molecules are further apart from each other and has a high pressure, lower pressure. Okay. This is the graphical representation of longitudinal. Series of compression. Look, this is the rarefaction. This is the center of rarefaction. This is the rarefaction. This is what? Compression. This is what? Rarefaction, compression, and so on. Wavelength distance, if you remember, distance between two successive equivalent points, okay, which are vibrating exactly by the same phase. I will explain to you the same phase later on. بالأو level now, بس just for O level كنا ناخد الديستنس من crest لcrest or trough to trough. هذا wavelength. Okay, or between center of compression, this is the center of compression, to the center of next compression. This is the best way. This is the wavelength. Okay, center of compression to the center of compression, or center of rarefaction to the center of rarefaction. And I may take this center of rarefaction to center of rarefaction. This is what? The wavelength. Frequency, it's number of waves per unit time. Unit hertz. Frequency, if I want to find it, طبعا كدefinition that pass a fixed point. We have to add this. Any number of waves per unit time that pass a fixed point. Unit hertz, if I want to find the frequency, I have to divide the number of waves per unit time. This will be used frequently in practical external. The frequency 1 over the period. Period, it's the time taken for one oscillation. Okay. Time, if I want to find the time taken for one oscillation, I have to divide time by the number of waves. Okay, time by the number of waves. اليونت للتايم second. طارق.
استاذ برضه بيكون البيريد هي برضه 1 over f ولا لا؟
Definitely.
Okay.
يعني البيريد هي 1 over f. هي inverse proportional. Okay, guys. Now we have to know how to measure frequency. We have to know how to measure what? Frequency. Okay. In order to measure frequency, we use something called oscilloscope. You will be asked about that, guys. Pay attention. The oscilloscope, something like this. I want to show you this now. هذا الأوسيلوسكوب هيك يكون screen. Like what did you see here? On the screen, we will observe waveform like this. But guys, I can't control this waveform. I can control this waveform by something called time base. This is called what? Time base control. We have something called voltage gain. Voltage gain control. The time base controls the period. والvoltage gain controls the amplitude. I will show you how. هذا هو الأوسيلوسكوب. Right, this is what الأوسيلوسكوب.
If we go 2 volts, it should go up to that first line. And do the same thing, only going in the other direction. 4 volts AC. So I have that hooked up, and we can see what's going on.
Okay, guys. If you look to this, here there is a waveform on the screen. Okay, if you see it. Here we connected something. Just a moment, please.
On here. Right, the first thing we notice.
Okay, guys, look to this. This is called oscilloscope. Guys, in this oscilloscope here, there is something called Y input. In this Y input, guys, we connect the source that we need to measure its frequency. Like sound, let's say, مثلا, I may connect here microphone. I may connect here what? Microphone. If I connect here microphone, I will be able to measure the frequency of this sound. Okay. Here there's called voltage gain. Here there's called time base. Okay, guys, a time base, listen to me please. A time base will control the period that will appear where on the screen. And I may control the period. I may control the waves that will appear on the screen. Look here now.
Notice that we don't have a continuous positive, or also known as negative, and then about I see within the screen. This is very useful for looking at alternating current or RNA cycles. A little bit more.
Okay, guys.
Would be 16 volts. So just for fun, I'm going to turn this time scale just so that you can see what happens when I change it. You can.
Did you see here using a time scale? Using the time scale, he can control the number of waves that will appear on the screen, right? Accordingly, we can control the period, frequency on the screen, not the actual period on the screen. So I may measure this using the following concept.
Stretch this out. There's this little knob in the middle that if I want to change how many cycles I see within the screen. This is very useful for looking at
Okay, guys, pay attention now. Hello, here, look to the time scale. The time scale here is 5 milliseconds, right? 5 milliseconds. Right? How can I measure the frequency, let's say, of a microphone that's connected here, using what is it appeared here on the screen? Hello, here, guys, I have to measure the distance between peak to peak. Here, approximately 1, 2, 3, يعني around 3.1, something like this, or 3.2 maybe. It will be very clear in the past paper. So first of all, guys, to measure frequency, I have to measure peak to peak distance. Peak to peak distance, okay? Peak to peak distance. Then I have to multiply this peak to peak distance by the time base. Okay, by the time base. Here the time base 5 milliseconds, right? Here the time base is 5 milliseconds. So I can multiply. This is the period, guys. If I multiply peak to peak distance by the time base, I will get the period. And here 3.2 times 5, which is what, around 16 milliseconds. So the period here is 16 milliseconds. If I want frequency, I have to divide 1 over period. Okay? So in the external, guys, you'll be asked to draw this. بس هون احنا we don't, it's يعني it's not a wavelength. You can't count the time here, Tara, by the way. You can't count how many periods here divided by this. But the best way انك تاخذ ايش peak to peak period, distance وتضربها بالتايم بيس اللي هو ايش بنسميه احنا التايم بيس.
ايش بيفرق التايم بيس عن التايم العادي؟
التايم بيس قديش الويف بتاخذ time to pass this square او this unit. اوكي this unit يعني حتى التايم بيس بيكون محطوط بالسكند سوري بالسنتيمتر. يعني هلا الويف travels from this point to this point صح؟ disturbance يعني I meant disturbance it travels from this point to this point. The time needed here for this disturbance along according to the screen in front of us, the time needed to travel from this point to this point is 5 milliseconds. Okay, 5 millisecond. يعني in other words 5 millisecond per centimeter. Regularly high 1 centimeter. Okay, فالwaves
اوكي نضرب ال number of squares بالتايم بير كيوب او السنتيمتر
per square or per unit. Yes, exactly. Okay, fine. So here, as what we mentioned before, there's something called Y inputs. And the Y inputs, guys, I may connect the mic. Accordingly, I can calculate or I can measure the frequency. To measure the frequency, I have to multiply peak to peak period or peak to peak distance times the time base control, right? Times the time base control, then find the frequency. Guys, these steps, and you will be asked about these steps. Okay? If I want to find the amplitude, I have to take, look here, look to what I wrote here. Vertical peak to peak distance. What does this mean? This part. طلعوا معي. Pay attention, guys. This part. From this to this. هذا double الامplitude. رح نحكي عنه later on. هذا double ايش؟ الامplitude. To find the amplitude, you have to take the vertical peak to peak distance by 2, then multiplied by something called voltage gain. I think you will not be asked about this part. This is just in case you are asked about it, but it's not including in syllabus explicitly. We are asked regularly about how to measure the frequency. How to measure what? The frequency, not the amplitude. But if I want to measure the amplitude, simply I have to measure vertical peak to peak distance divided by 2 multiplied by the voltage gain. Here, guys, we have two different definitions. We have to distinguish between them: displacement and amplitude. Displacement and amplitude. Let me back to the snap tool that I used here. Okay. Okay, guys. This line is called equilibrium position. Equilibrium what? Position. Guys, the equilibrium position, which means there is no disturbance, and if there is no disturbance, all the particles lie on this line. Okay, fine. If there's a disturbance, the particles will be displaced from the equilibrium position. Displaced here from the equilibrium position. This is the displacement of the first one. This is the displacement of the second one. Displacement of the third one. Displacement of the fourth one, and so on, guys. Clear? The maximum displacement, this position, it's called amplitude. The length will maximum possible displacement for any particle. Maximum possible displacement for any particle. It's called amplitude. It's called displacement. Amplitude. Okay, guys? Any question about that? Like this. This is amplitude. This is what? Displacement. The main problem actually, guys, how to determine the amplitude where in a longitudinal waves, not in a progressive waves. Okay. Pay attention now here. Just a moment, guys. Guys, look to this. Let's say that here, these are planes, undisturbed planes. Okay, guys, this one, undisturbed what? Planes. And before producing sound. Here, the second one after the sound propagating where after the sound propagating بالاir, right? Now let's compare. Look here, please. This is the undisturbed position. This is the amplitude here. Sorry, not the amplitude. Sorry, this is the displacement. Right? This is what? The displacement. Look, this is the displacement of the red plane. If I take this pink, had the undisturbed position, this is the displacement of the pink one. Here, again, this is the displacement. Here, there is no displacement, guys. Where is the maximum displacement? This part. The maximum, right? So this is the amplitude. This is what? The amplitude. It's the maximum possible displacement for the planes of air from undisturbed planes or undisturbed position. The sound waves.
أستاذ ما فهمت شو قصدك؟
Let me repeat. In order to find the amplitude, guys, I have to compare a disturbed plane, الwave شايفينه? Sound wave snapshot مع undisturbed planes. Because the amplitude هو maximum displacement from the undisturbed planes. فرجوا معي هون. لو أخذنا هذا البارت هذا undisturbed صح عامر؟ extend it. هذا الديسبليسمنت تبعنا تاع هذا البلين. تمام، هذا الديسبليسمنت تاع هذا البلين. Let's take the second one. The dashed line, guys, that I draw is the undisturbed position. This is the displacement for, let's say, the pink one or the purple or whatever. Then this one, this is the disturbance. Here we don't have any disturbed or any movement of the plane. هلا أنا I draw here 3 displacements, guys, right? Which of them is the maximum? البينك هذا راح يكون عنده maximum displacement from undisturbed position. هذا بنسميه الامبليتيود. هذا يعني لو قست هاي الديسبيسمنت، هاي الديسبيسمنت if I measure it، هاي راح تكون الامبليتيود. اوكي. طيب هلا عندنا تو ريبريزنتيشن للساوند كنت انتبهوا عليهم، represented by displacement و represented by pressure. الديسبيسمنت زي ما انتم شايفين هون عند الماكسيموم. لو انا if I extend the line، هون عندنا maximum displacement تقريبا اللي هو الامبليتيود، right؟ هلا البريشر جايز عند الماكسيمم ديسبيسمنت البريشر شو بيكون؟ زيرو. دائما البريشر عند الماكسيمم ديسبيسمنت بيكون ايش؟ زيرو، ما في بريشر. وين الهايست بريشر؟ هون هاي الريجن، صح، اللي هي السنتر تاع الكمبريشن. هذا بيكون عندنا هايست بريشر. if I extend this راح يطلع معي هون هي عند الريجن اللي فيها هايست بريشر بيكون عندها الديسبيسمنت كم؟ زيرو. واللوست بريشر بيكون displacement زيرو، والhighest displacement دائما بيكون عنده pressure ايش؟ Presentations of waves. عندنا two graphical representations. بالO level we did not talk about them صراحة، بس بالA level we have to. First one, it's called a displacement distance. yeah. نايم بابا، تعالي انت ارسم، شو بدك في عمر؟ تعالي هون، نايم على سريره، روحي نامي بابا. طيب I'm sorry for that. طيب guys، فعندنا displacement distance. displacement distance graph show the displacement of series. ركزوا على series of particles along the ray of the wave at one instant in time. يعني زي ما عملت أنا هون، تفرجوا. I take snapshot here. okay. I took here a snapshot, right, at certain time, at certain time. هلا هذا it's called displacement versus what? Distance. Series of particles at one time, right? هلا distance من peak to peak هاي رح تعطيني wavelength, right? يعني here for example I recorded what? To draw this graph I recorded displacement مع distance. okay. يعني here مثلا let's say 1 هاي 0 هاي 1 مثلا 2 3 4 5 6 7 and so on. I recorded the displacement تاع هاي particle والdisplacement مع هاي والdisplacement and so on in this way. Displacement of each particle at certain distance. I recorded distance versus displacement or displacement versus distance. Then I graph displacement versus distance. I will get a form or a waveform like this. If I took, guys, the distance between peak to peak here, I will get the wavelength. Okay, I will get what? The wavelength. So we have two graphical representations for any disturbance or any wave. The first one is displacement distance. I took the displacement, or recorded the displacement for series of particles at one instant. So I will get this. Here I can determine amplitude, wavelength, and the location of crests and troughs or compressions and rarefactions. The other representation is displacement time graph. Displacement time graph showing a variation of displacement, guys, of one wave particle with a time. يعني here, if I go back to the simulation here, let's say I want to record the this one. Just a moment. This particle. يعني هلا معي stopwatch, right? I'm recording what? Displacement with time. Sorry, هون بكتب الشكل. Okay, anyway. I'm recording displacement for time بس لهذا البارتيكل. بس displacement مع time. يعني at each instant. يعني هون في عندنا timer شايفينه. I'm recording displacement and time for one particle. If I record this, I will have record displacement مع time. If I graph this, if I make a graph for this values that are recorded, I will get a graph displacement versus what? Time. From displacement versus time, guys, I can control or I can find what? The period. I can find the period as well. I can find also, or accordingly, I can find the frequency. Right? I can find what? The frequency. Then صار عندنا two graphical representations of the disturbance or waves, displacement distance, displacement time. Displacement time, we can find the amplitude, period, with direction of motion travel at a particular of the particle at various time. Here I can find what? Wavelength, also amplitude. I think all of you familiar with that. The speed equals distance over time, or wavelength over period, right? If I want the speed equals frequency times wavelength. All of you familiar with this one? Okay.